Hi, in this video, we want to take a look at using SMOTE to deal with unbalanced data. Okay, so here's the idea. If I have a classification problem, I'm doing supervised learning, my target variable is categorical, and it ends up that I don't have the distribution, the sample distribution of the target variable that I need. What can I do about it? Well, one thing that we can do is if we're in the situation where we have very few observations for one or more of the levels of the target variable, we can create synthetic data, AKA fake data. All right, well, so first and foremost, well, like, whoa, synthetic data, I'm kind of like not okay with this. Well, we might be in a situation where we just have very few observations. And if I try to run with it, with the data that I have given, it just won't work out. My model will not be able to fit if I have just very few observations. Let's say one of my levels only has 2 observations. There's not really a whole lot I can do. I have to, either I don't build the model, or maybe I could bin a minority level with another level. That might work. But if I absolutely need to make predictions, including that level, I need to get data somehow. Another situation where we might want to do this is that a class of our target variable is underrepresented compared to like the known proportions. So for example, if we had data that includes race, and we knew that the sample population at certain proportions, and then our sample proportions don't match, well, what I could do, I could use SMOTE to kind of create synthetic data that hopefully matches the true population for the minority group. Now, in general, it's much better to use weights. In a lot of cases, I would just use, I would change the weights of observations to deal with this, but sometimes it's not feasible. If I have very few levels of the minority level, very few observations of the minority level, then I really don't have anything else I can try. There's nothing else I can do. Another situation is that the desired supervised learning algorithm does not accept weights. And if it doesn't accept weights, I can't use weights for that. So there's just times that this is just the best option that we have. Or the best option that we have is to create synthetic data. Now, how to create synthetic data, there's another way called rows. Another option would be to upsample or downsample our data. But once again, all of these have advantages and disadvantages. SMOTE is one of our options. So let's run through an example. Let's load the data. So here, what we're going to do, we're going to use the oil data from Carrot. So in that, there are 2 actual sets of data. There's oil type, which is the target variable, but there is also the fatty acid data set, which is the collection of predictor variables. All right, so if I look at oil type, so we have oil type A, B, C, D, E, F, and G. Okay, so we want to build a predictive model, or excuse me, a supervised learning model where I have 7 levels of my target variable. Okay, so something that should jump out at us immediately is that G has only 2 observations. C only has 3. All right, so right off the bat, if I attempt to fit a model with this, with G only having 2 observations, I'm putting a lot of faith into those 2 observations. And honestly, if I could avoid it, I would not want to be making predictions that include the level G. Now, one option that I would have would be to, if it's appropriate for the problem I'm working on, I could bin G with another level that I know using subject matter knowledge is similar. Okay, but that might work. That may not be possible for the situation that I'm in. And so then what do I do? If remember, I'm an employee and I'm being asked to create a model, and I need to make a good model because I want to continue being an employee. If I didn't want to be an employee, I wouldn't be in the situation I'm in, building a supervised model with insufficient data. Okay, so what I'm going to do, I'm going to create synthetic data. Oh, and here are the observations that I have to work with. So over here on the more left-hand side of the data, these are my predictors, and here's my target variable. And these two observations are all I have to work for level G of oil type. All right, well, all right, so here's something I would do if I had the option of binning my data. I would go ahead and look at the principal components of our predictor variables and then plot each of the, or use the colors to determine the points in the scatter plot. If I take a look, so here's the principal component analysis, first two principal components of our predictor variables, and I'm coloring them by the level of the target variable. All right, so the yellow, it might be hard to see, but right here there's yellow, and that is G. So these two are my two observations for G. And if I remember correctly, C only had 3 observations, so there's C. So I don't have a whole lot to work with these two different levels. So something looking at the data, since I don't have subject matter knowledge on this project, I don't know anything about oils or fatty acids or anything like that. I don't have a background of that. If I didn't know better, if I had the option of binning my target variable, I would combine E and G, and then my modeling would be, for that level, would be E or G. And possibly with C, I would put D and C together and then into one level that I would label as C or D, like that. That's if I have the option of binning my target variable. If I don't, then I need to come up with another way to proceed. All right, so now I'm going to go ahead and run SMOTE. Now here I'm just going to use the default settings. So what SMOTE does, it takes neighbors of a particular level and it uses those levels to make synthetic data. And the perk over, this tells us, this controls how many from the minority level for us, that's G, will be generated. And perk under, this controls how many of the non-minority level will be generated. And for us, that's all the non-G. So that's A, B, C, D, E, and F. All those are controlled by this parameter. And this controls the number of G observations. All right, well, let's go ahead and run it. All right, so my output is going to be a data frame. Oh, and this is from the DMWR package, so data mining with R. This package was built up for the purpose of supporting a textbook. It's a pretty good textbook if you want to go through. It's kind of tough sledding if you're going to get through all of it. I worked out every line of code in that book way back in the day when it first came out. But the package has not been updated since 2015, so it's not a very active package. So as R progresses, this may become an outdated method. All right, so the SMOTE algorithm generated data, and we can see that we have 1A, 4B, 0C, 0D, 2E, 1F, and 6G. All right, so we have more observations of G than we had in the original data, and we have less from the rest. So the SMOTE algorithm, using the default setting, will actually increase the minority case and decrease the non-minority case if we leave it as is. And here, just so we can see what the original was, here are the original counts for our target variable. And so we can see that across the board, every single time for non-G, the number decreased compared to the original data, and the minority level, G, increased. Okay. Now, something about this, if I go ahead and print this up, for some reason, I don't really understand why the algorithm does it. This generates missing values. All right, so every time I ran this, I played around with this before making the video, and every time there was one missing value, the entire row of predictors had missing values. So my opinion from working with this is that if you're going to use this implementation of SMOTE, you want to run complete cases before you start using the data. So complete cases will wipe out any observations that have one or more missing values on the row. Now, something else I want to point out about this is if we go through and let's say this time, I'm going to really crank up the number of the minority case generated. And I'm going to keep this the same at the default level. So this default is actually relative to the perk over value. And it's going to generate some missing values. So I'm using the complete cases function to get rid of anything that's missing. And after I do this, here we can see that now we have more observations in our data for A, B, C, D, E, and F, and we have more observations for G. Now, how does that compare to the original? Well, down here is the original. So we can see that, all right, so G, it's not the most frequent level, but now it's the third most frequent, which is a huge jump from where it was. Here's the original. Now, but there's a catch with this. If I go through and I just take the unique observations, I can see that about half, roughly speaking, of the G observations are not unique. And I can see that really what happened for A, B, C, D, E, and F, it was just upsampling. It was just grabbing the original values over and over and over. So if you're going to use the data mining with our package for SMOTE, you have to realize that really you're only generating synthetic data for your minority level. The rest are just getting upsampled. So why do we care about this? Well, what we want to do is if I want to get synthetic data for more than one level, what I have to do is I get synthetic data for the smallest, least frequent level, the minority level. Then I grab everything else that's without that one minority level from the original data set, and I rerun it with the minority level removed so that the new set has a new minority level. And I can keep on doing this over and over to get synthetic data. All right, so now let's go ahead and take a look at what the output really looks like to give us a better feel. So this is just the same code as the previous, except I'm running it on the SMOTE data. So I'm doing principal components and I'm plotting the scatter plot. Now you'll notice that principal components, it flipped axes, and that's okay. It reflected, it doesn't change anything for this purpose. Now when I look at the yellow, I can see that it just kind of runs as a straight line. That's interesting. All right, well, that's all I've got for you. Take care and goodbye.